Hi, welcome back. So in this video, I go ahead and try and repair this fan I got from Temu. Well, I was gifted from Temu. It's one of those humidifier fan blower things. So we got two of these. The one I was gifted, it broke on day one, and no surprise there. And this one broke after a year, but it had life in it. So as you can see, you press the LED button and it kind of shows it's coming to life, or there's something there. So I go ahead and take a look at it, and let's just get into this repair, shall we? Let's do this. Right, 6 screws.
For someone who's a Shaolin monk, your kung fu is really lousy.
Right, the next thing I'm doing here is hooking this up to my bench power supply at 5 volts. I think I did it at 1 amp. Just to check if the fan's working, and lo and behold. Right, so we know that the fan works. Now it was time to check if the 5 volt was coming in through the USB-C port to the board, and we should see 5 volts on the multimeter. And that's exactly what we get. So we have eliminated the fact that this part of the contraption works fine, so we can move that aside. And right, just a quick overview of how it all works. So power comes in from the USB-C here, provides power to the motherboard, provides power to the fan, and then it also gives power all the way up to the humidifier. So you have a better understanding of how it all works, and it doesn't look as daunting as it might initially seem. So we move on, and I take out the motherboard, and I spot right there corrosion. So I think we're done. Give it a good clean, take off that corrosion, and then hook it back up together, and we'll go from there. So I just scraped it off with a little bit of pliers that I had. I wasn't convinced, so then I used a grinding pen, just so the contacts were a little bit more bare and less of that corrosive stuff on it. And then I went ahead and checked for continuity, and everything checked out. So I put it back together, and it went from there.
Aha, LED.
That wasn't an aha moment, because that was the same behavior we had before, where you would press it and the red LEDs or the LEDs would come on temporarily. So I went on to check and rule something else out, and that was the connector, the one that you see connecting the motherboard to the humidifier board.
Yep, 17, yep, 13, 14, 15, 16, 17, 8 pin. Okay, so the connectors are fine.
Right here, I think, okay, now let's check voltages. So I find the ground point that's on the pin of the connector, and I start checking for 5 volts anywhere I can, starting from where the connector is. So checking the transistors, and they give me around 5 volts. The multimeter's of course there. Checking really anything there that should give me 5 volts, and it does. Then I go past that big microcontroller chip, and I don't get 5 volts anymore. I barely get a volt, and I keep doing this. I keep checking, but I don't get what I need. So that's where I start to suspect that big microcontroller chip. I think it's 8 pin each side, 16 pin. So yeah, you can see everything else is giving me half a volt. So I feel like I'm onto something here. So now we're gonna go and check the microcontroller. And this one here, pin number 4, I want you to pay attention to. This is 3 and this is 4. Look at that. 10 millivolts, barely anything we got from there. The rest we were getting around 200 millivolts, and sometimes we were getting nothing, just like that. So we were getting 3, which is basically nothing, just resistance, probably, not resistance, voltage. we were barely getting anything. So
I don't know, that looks very dodgy.
yeah, so it's not a good sign, and it wasn't a good sign.
Very dodgy.
So at least we know. I put it under a thermal camera and nothing lit up. In hindsight, I think that big microcontroller chip should have lit up, but it didn't, and I didn't think much of it at the time, but I did still suspect it. But right now my eyes were on these Y1 transistors, because it wasn't, I mean, spoiler alert, it wasn't them, but they were giving me these readings. So it would give me 100 kilo ohms, 100 kilo ohms, and then I would check again and it would give me 58 or 60 kilo ohms. And I would keep going back, and then they would just give me these 100 or 60 kilo ohms, 100 or 60. So I went ahead and wasted my time and I replaced one, and surprise, surprise, nothing happened. Yeah, so nothing changed. The readings were exactly the same, and when I connected it up, it gave exactly the same behavior. So that was it. What would I do? What would any of you do after this? Then I had the bright idea. Well, I have a donor board essentially. Why don't I go the one that I initially had, the one that was gifted to me, the one that conked out on day one. So why not try that one? Let's see what that's got. Let me see, because right now I'm thinking, okay, the transistors, the Y1s, okay, they were fine. So the only thing that's left is that microcontroller. Maybe it's in the other one. It has to be in the other one. So that's what I do. I opened it up, and it doesn't have the same fault. But looky here. Heavy corrosion on that capacitor. And these came off, but very stubbornly. And no, the power connector looks like it just fried. So, considering the other one doesn't work, this portion of it did work fine. So I'm going to replace the capacitor from the donor board, or the other one, clean it up, the corrosion. If it works, great. We'll use this portion with the other portion of this. Hopefully this works. At least we'll have one. Let's see what happens. So this one had some sort of burn or explosion going on inside. I think I'll show later on what happened to the plastic around it in the case, but this was toast. But I didn't fancy myself doing this without a microscope, so I get the microscope out and I go under the cam, and hopefully you can see that better. The capacitors, nearly all SMD components, have two sides to them. You can see on that 104 one. This one, the metallic on one of them, is completely gone. It must have been that bad.
You're one ugly motherfucker.
And you can maybe see around it as well, there's part of the solder mask, whatever it is, the printed PCB part of it, it's off. That's actually a bare ground there, caused by an explosion or whatever happened. Corrosion, water contact right next to the power input. So I got the donor capacitor from the other board and put it on, but it was still, the board was still blown, so that bottom pad wasn't really making a good connection. So I had to use a grinding pen, because it's on a ground plane, extend that pad, and then the like you saw, it just comes off. So it was good that I had to ground it down. I tinned it up and then put the capacitor on, and really nice, it made a nice connection. Then check everything. Yep, it's not going through continuity wise, and everything else, positive, negative was making a connection. Then I found the PCB from the water damage or corrosion. I dug up what I could, wherever was flaky, covered it up with solder mask, and then even the capacitor, for good measure, future-proofing it in a sense. then UV light, bake it, and boom, that was done. It was solid, and we were ready for testing, I guess.
Oh. By some miracle.
So we got it working, great, but I wanted to double check the voltages and the differences from the other board. So I started with that chip, and lo and behold, pin number 4 was giving me 2.2 volts opposed to whatever it was before. It was like half a volt, or was it 10 millivolts, I think. So that's a big thing, isn't it? Because it shows that the microcontroller chip was the issue on the other board. But the sad thing is you can't do anything about it because there's no markings on there. So you can't really buy or replace the chip because you don't know what it is. There's no value or identification for it. The rest of the pins on that chip were giving me hardly any millivolt readings, but pin 4 was giving me that 2.2, and the connector was also giving me a nice healthy almost 4.5-5 volts. So I'm guessing that the microcontroller should be working on and off or give certain voltages when certain functions are working on the system. So it makes sense. So putting that fixed board back in, I realized that there was quite a bit of an explosion. I mean, check the damage. So instead of just putting it back in and plug it in and thinking, okay, it's going to be fine, I'm just going to be delaying the inevitable. It's going to happen again. So now I want to modify it. But before that, we need to figure out how and where the path of water traveled and how we can stop it. So there, I'm seeing that it's obviously coming from where the water gets sprayed out, and where the leak might be. Comes from the top, trickles down, and then somehow works its way to the connector, to the motherboard, and eventually to the sensitive voltage input parts, or the electrical input parts of the PCB or the motherboard. So we need to nip this in the bud, and that's what I do. I show you that we need to get the humidifier and make that watertight. That's the goal, opposed to gluing the motherboard or making it waterproof. I think that's just a waste. So to seal off and do what TEMU should have done, to seal off and make those parts of the to make the humidifier watertight. So let's get to the modification.
The water is all coming from here, so I need to hot glue in a semicircular fashion here.
You know what I mean?
I hate working with hot glue because it's time sensitive and very messy, but you see here I'm going for it. I'm putting it in that semicircular fashion and trying to go as fast as possible, trying my best not to get it anywhere near the center, and then I just say, well, since we're here, let's just go and get everything covered, but not too much.
Quickly.
And then once I had a good hold of it, it was just a case of getting the screws and tightening them down one by one. So I won't bore you with that too much, and I'll just fast forward it until it's all secure and down. I managed to get whatever I wanted onto it, but then the hot glue was still hot. So I thought, why not just go crazy with it and put it anywhere where there's a potential for water to leak. So from the bottoms and the sides, I tried to make it all watertight, and look at it, it turned out really well.
What's this for?
And then I went a little bit crazy and thought, well, why not go for the motherboard, because I don't want to take any risk with this. So anywhere where I thought that the water may or may not travel, I started to hot glue it down. And finally it was time to put it all back together and test it with some actual water inside. So just quickly going to speed run the putting it back, popping some water back into the top and testing it. Boom. All working fantastically. Firing the cylinders, fan, the lights, very bourgeoisie. But I needed to be sure, so I got a paper towel and I opened it up again just to see if there were any leaks anywhere where they were before. So I start probing the motherboard, the connector, anything I can to find water. But yeah, it was good. Nothing was there, no water droplets. I really pushed it in anywhere I could, the crevices, and I think we've done a really good job, watertight. And the only thing now to do was to put it back together. Okay, all done. I'm happy with that. And that's it really. I hope you learned something from this, got some tips and tricks from this repair and modification. It was a bit of a difficult one for me to do, to edit this, because I wanted to do a video on the dangers of this and how TEMU can get away with these sorts of things. But my next video, or following up a video, is going to be on exposing TEMU and have a lot of points and a lot of research on that, so stay tuned for that. But thanks for tuning in, and all the best. Take care, bye.
So you've learned the top Shaolin style? I have had the I Ching manual for 12 years. If I had not mastered it by now, I'd regard myself as an idiot.